Welcome to this video on linear inequalities. This is really a review topic to set us up for our system of linear inequalities that we will begin next. So by the end of this video, you should be able to graph a linear inequality on a coordinate plane using the proper dotted or solid line, and you should be able to shade the appropriate solution area for the graph of a linear inequality. So, what is a linear inequality? A linear inequality is similar to a linear equation, but uses inequality symbol. So we could have a greater than, or a greater than and equal to, or a less than, or a less than or equal to. So instead of an equal sign, we'll have one of these inequality symbols. The solution to a linear inequality is all ordered pairs that make the inequality true. When we draw the inequality line, you will shade one side of the line or the other based on the inequality sign, and any point that is in the shaded region will make the inequality true. So inequalities have many solutions. Equations, linear equations, have one solution. Or remember, we had those three choices. They had one point where they crossed. They never crossed because they are parallel, so that would be no solution. And then there is infinite solution if it was the same lines, because we're talking about the individual points, but an inequality, anything in the shaded region will make the inequality true. So determine which ordered pairs are solutions to the linear inequality below. So what we need to do is remember an ordered pair is x comma y. We're just going to plug in the x and the y to see if it makes the left side of the inequality less than 15. So if x is 2, so I'm just going to plug in 2 minus 3 times y, which is 5. What do I get there? I get 4 minus 15, which is negative 11. Negative 11 is less than 15, so that point would make the inequality true. Let's try again with negative 1, negative 7. So we have 2 times negative 1 minus 3 times negative 7. So that gives us negative 2 plus 21, which equals 19. And if we compare it, 19 is not less than 15, so negative 1, negative 7 is not a solution here. All right, try it again with 3, negative 4. 2 times 3 minus 3 times negative 4. 2 times 3 is 6, plus 12 is 18 less than 15. Nope, that's not a solution. Let's try 0, 0. 2 times 0 minus 3 times 0 equals 0. Is 0 less than 15? Yes, that's another solution. Okay, so your inequality can have more than one solution that makes the inequality true. So a couple things we have to remember is when we are talking about our inequalities is we always want to put them into slope-intercept form. Just makes it easier to graph. Remember to flip the inequality symbol if you multiply or divide by a negative number. So that's pretty important. Remember to flip the inequality symbol if you multiply or divide by a negative number when you're rearranging your equation. Now, once you're in slope-intercept form, we're going to go to the graphing part. You're going to use a solid line if you have either of those symbols. If it's an equal to, we're going to use a solid line. You're going to use a dotted line if you're a not equal to symbol. Okay, because that means it doesn't include any of the points on the line. It's like having an open circle when we did some inequalities before. Now shading. Shading is where we kind of struggled, so hopefully we'll be able to pick this up this time through. You're going to shade above the line if you have a greater than or a greater than or equal to sign. That is going to be above the line. So you're really, what that means is where the y values are greater. Okay. Then you're going to shade below the line if you have a less than or a less than or equal to symbol. That's where the y values are smaller or lesser. Okay, so let's try one just to kind of remind ourselves what to do. First, we need to be in slope-intercept form. So I'm going to move the x to the other side of the inequality. And I have negative 3y is less than, remember this is slope-intercept form, so I'm going to put the x part first, negative 2x plus 15. I need to get y alone, so I'm going to divide everything by negative 3. These cancel to a positive 1, so y, I divided by a negative number, so my inequality is going to change directions here because of that. Then I have negative 2 divided by negative 3, leave it as a fraction, becomes positive 2 over 3x. That's our slope. Positive 15 divided by negative 3 is negative 5. Okay, now to graph it, we go to our y-intercept, negative 5, 1, 2, 3, 4, 5. And we're going to graph our slope, rise 2, run 3, rise 2, run 3. Rise 2, run, we're going to run out of room, so I'm going to just kind of take it right off. Now before we draw the line, we have to verify, are we going to do dotted or solid? This is not an equal to, so we need to have a dotted line. So any point on the line is not a solution. And this says y greater than, so always start at the y-intercept. Where are the y values greater than negative 5? If I go down or if I go up? Negative 4 is greater than negative 5. Negative 3 is greater than negative 5. So really, I'm shading any point here. If I plugged in the x and the y like we did up here in this example, it'll make the inequality true. Any point on the line will not make the inequality true, and any point below the line will not make the inequality true. Okay, and it's not just limited to just this this little piece that we can see. The coordinate plane goes on and on and on. So it points out over here, up over here, points that we can't really see, they would also work for a solution. All right, let's try this again. Go ahead and flip this page over. All right, let's try number 2. 2 is already in slope-intercept form. So we're going to start at our y-intercept of negative 1. And then we're going to count our slope. You know, I'm going to put it over 1 to help you see it. That says go down 2, right 1, because the 1 is positive. Down 2, right 1. Down 2, right 1. Okay. What if I felt better if my line was a little bit longer before I drew it? I can, instead of down and right, I can count up and left. So I'm going to count up 1, 2, left 1, and you can see how my pattern is continuing. Okay, that sometimes helps us make a better line. Before I draw my line, I have to verify am I dotted or solid. This one's going to be solid because of the equal sign underneath. So I'm going to take my ruler and I'm going to draw my solid line. Okay. And the last part is we have to decide where we're shading. This says the y's are less than, so go to the y-intercept. Where are the y's less than that y value of negative 1? All of these y values are less than, so that's the side that we want to shade on. So this is our solution area. Any point in the solution area or on the line will make the inequality true. Okay, let's try number 3. So looking at number 3, it's not in standard form. So to make it in standard form, we were going to move the x value to the other side of the inequality. So I get negative 2y is greater than negative 5x plus 12. Then we're going to divide each thing by negative 2. And I'm going to get y, and I divide it by a negative, which is going to make my inequality change directions. Negative 5 divided by negative 2, they become positive because it's negative, negative. X. Positive 12, negative 2 becomes negative 6. So your y-intercept is -6. 1, 2, 3, 4, 5, 6. And my slope is rise 5, run 2. So 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. All right, dotted or solid. Looking at this, it is a dotted line because there's no equal to. So I'll make my dotted line. Now my shading, it says the y values are less than the line. So go to your y-intercept where the y values less than -6 down here. So that makes it this side of the line. Okay. So now we have a couple special cases that I want to remind you of. Let's take a look at number 7. That just says y equals -4. Y equals -4 is a horizontal line at -4, where y is -4. 1, 2, 3, 4. Because y is -4 on this point, and this point, and this point, and this point. All of these points have a y value of -4. So that's why it's going to be a horizontal line, and it's going to be a solid line because there's an equal to. Okay. This says the y values are less than -4. So here's my y-intercept at -4. Where are numbers less than -4 for y's? And that would be down. So our solution area for this problem is right there. Now our last special case, we have x is greater than a number. So x is greater than 7, so we want to find where x is 7. 1, 2, 3, 4, 5, 6, 7. But x is 7 here, and here, and here, and here. All of these points has an x value of 7. Okay, so we want the whole vertical line right here. But it needs to be a dotted line that we're drawing because this is not equal to, so I'm going to make a dotted line. I don't have the y-intercept here, so I'm just going to go where x is 7. Where are the numbers greater than 7? To the left or to the right? And that would be to the right. So anything to the right of that line, but not on the line, would, if we plugged it into this inequality, would make the inequality true. Hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.